discussing Gen AI tools for enhanced software engineering.
Yeah, so today we're going to be looking at how to use it for coding, but then I'm just going to give a quick overview just around where it came from, different other areas that we have before we sort of dive in. So there's about 5 or 6 slides that we have. So I suppose the core principles here, prompt engineering, it's about, I suppose, the clarity of your queries that you put together in the first place. So it's teasing out what you want. So it's not like the one-shot question of going, in that case, how do I code? You have to be more specific. You have to say, how do I code Python to be able to connect to a database? And this is the type of functionality that I want to be able to do with that database, writing, reading, etc. And it's sort of about looking at connecting to the database. You would look to design, first of all, be able to design it, pull out the structure of what you want for the database, then to be able to actually write the code to wrap, to talk to the database, and then to actually, I suppose, create the front end. So today we're only going to be looking at generating sort of functionality that we use for our search part of our application that we have. So, and again, it's just it was an idea to test out the theory, to be able to sort of see how it worked and how far we can push it. So this is basically a Google Trend sheet. It shows 2 queries, AI and ChatGPT and LLMs, which LLMs are large language models. We had Chris Watkins, who is the professor of AI, speaking. I think it was back in March, wasn't it?
Yeah, I think it was. Yeah.
From Royal Holloway, which was absolutely brilliant. I think hopefully we get at some stage to release that audio that we have for that, because that was really interesting. He gave an in-depth view of how transformers worked. What you can see from here is obviously from the background levels of search, AI has always been there. It's always been used with coding. And you can see that blip then in sort of the end of 22, start of 23, which was the first stage of sort of the large language models, and when ChatGPT was sort of originally released. So I suppose from the GenAI capabilities, kind of what we're looking at here is the different areas. Language, which is like text creation, text understanding, translation. From the image side, you've got image creation, image analysis, speech. You have, I mean, what we see nowadays in the Google Meet, the ability to, it captures, converts dynamically your speech into text that you can copy. And it also is now switched, and you can sort of do dynamic translation. So you're actually able to have conversations with people in different languages where they actually understand or can at least follow along. The other side, obviously, we've got video and music and sort of 3D models. Today we're going to be chatting through the code side of things, and I suppose primarily the areas in that we can look at. There's a couple of different areas. One in the code generation is you can have it sort of within your IDE environment. Good examples of this are the GitHub Copilot and also Amazon's Code Whisperer. Actually, see if I give you a quick example of. So in this scenario, you could start from blank. You might create. It's hooked in the background here, so you can tab to select it, create a new, and effectively, as these large language models are built on code that is crawled from GitHub and lots of different open source repositories, that it's actually able to, as you type, pick up what you're typing and predict what the next part is, which is all the part of what the large language models do. That's extremely useful in some of the scenarios for the Copilot, where you're actually able to go in, you can create as part of your comment what you actually want to do. And it makes a best guess at it and sort of pulls it back out. But then there's also the other parts where it can actually look at your code. When you actually go to write your comments about your code, You start with your first few words, and it actually has picked up the context of what you've written about and actually creates your comments for you. So it's a great tool that you actually use. It doesn't necessarily do all the coding. It'll do the initial parts, but you have to sort of do it and drive it. And as you're doing it and driving it, then it becomes more sort of adaptive. So you're actually able to effectively use it as a tool. It's not going to do your work for you, but it will help you do it. So that's code generation. The debugging side is, it's actually really, really good. If you're stuck on a particular error that you have with your code and you're racked your brains, you can actually copy and paste the error back in, and it kind of, within ChatGPT anyway, it'll give you a direction. Again, you got to give a context about what you're doing. So you say what stack you're using, what you're running it on, and then you paste in the bug. And for a large amount of time, it'll actually be extremely good to kind of point you in a direction towards fixing it. And some of the times it'll actually help fix it, but it's again extremely useful. And then the final part is sort of learning documentation. It's a fantastic way to actually learn new coding languages and to allow it to help you along to sort of, you can have a very quick idea of what you might want to build. It'll build you the code, and then what you can actually get it to do is to talk you through what it's done. And you can sort of question how each of the different parts work. So it's the type of thing that you can create yourself and then pop it into a debugger. And that's part of what we'll do in a bit, just to show you how that sort of process works. So I suppose challenges and pitfalls. You've got to be careful not to become too overly reliant on it, I suppose. It's very much, it's a large language model in the end. So it has set ways of doing particular things. You can use it to create starting points. Sometimes you can carry on through that, but you need to, I suppose, realize that you're using it as a tool, not as an endpoint. So it's not going to do the work for you. It's just a tool on the way to doing it. The other part is misleading answers. You should always verify the solutions. The downside is because it looks like it knows absolutely everything when you're talking to it. You have to realize that it's just predictive. It's predicted based on what it knows. So there, as it says there, they're not foolproof. And then the final part, which is it's using AI-generated code. So the code came from somewhere in the first place. So you've got to be very careful of, making sure that if you're using that code, that you put it to plagiarism software to check that it's safe enough to use. But again, as I said, it's not going to be generating the end software for you. It's going to be facilitating building it as you go. So I suppose for harnessing the best way of using it, there's multiple different approaches. You sort of have first approach is the iterative questioning. If you didn't get the right answer, you sort of tweak your question as you iterate through to get to a better, effectively get to the right place where you want to get to in the end. But sometimes it takes a little bit of a iteration to get through. The other part is where you have a sort of a large project that you might want to do. It's kind of where you'd end up doing that is you'd break it down to logical chunks rather than trying to put it all in at once. You sort of build up the idea as you go. And again, contextual understanding. The more context you give it, the better results you're going to get. If you think about it, you're effectively finding the right set of questions and slices across the LLM to actually generate the most applicable answer. So it's more of a sort of a conversation. So what we're going to do in the example that we're going to run through, it's one I've run through before and saved because I wasn't sure. Being an LLM, it's going to change as you ask it the questions each time. It comes up with different answers, so it makes it a very sort of difficult one to hit. So I've done one and we'll run through it sort of step by step. But what we're going to look at, we're going to explore a specific topic. It's OpenSearch, which is the Amazon search engine. It's based originally off Elasticsearch. And what we're going to look at is how we can enable synonyms to work with it in an easier way than it's currently set up. We're going to iterate through it to get it to give us some advice. So we're going to start with what we want to do, And then we're going to see through a conversation which way it kind of guides us from the information that it gives us. And then we're going to get it to use to build out some code. So what I'm going to do is I'll bring up the chat, and then sort of part way through, you'll see, I suppose, the answers come back. I'm going to take the code that it generates, pop it into a debugger, run it, and use it to verify and then feed back again into the actual, into the same conversation. We're starting off the conversation. Acting as an open search expert, can you describe what synonyms are in 50 words? We kind of limit it so we don't get too much about it. So I'll read through some of it just so we get an idea. So in open search, synonyms are alternative words or phrases that have similar meanings, and they allow for enhanced search flexibility. By defining synonyms, users can retrieve relevant results even if their query terms differ from the indexed content. For instance, cell phones can be synonyms with mobile, smartphone, broadening the search results. So effectively, we're looking at an explanation of what we want to be able to do. So then the next part is, I want to be able to programmatically add and update synonyms in the open search instance running on AWS. Is this possible to do with analyzers by adding a filter to an existing analyzer? So again, analyzers are one of the functions that OpenSearch uses to analyze the text before it puts it into the index. So it's just to see, is there a way of doing that? So it says here, yes, in OpenSearch, previously known as Amazon's Elasticsearch service. So it actually has a little bit of context in there as well. You can programmatically add and update them. So it defines the different parts you can do. So you can sort of see it defines the synonyms, update the analyzer, update the index settings. And then it actually gives you a very basic example of how you would actually update directly into the Amazon search with a JSON configuration file to actually do it and set it. And as you can see there, it puts in the synonyms, a laptop, notebook, and cell phone, mobile, smartphone. But the interesting bit's down here. Sort of shows you, if you're using the Amazon SDK or Boda 3, you can make these changes programmatically. And this is the interesting part here. It says after updating the synonyms are analyzed, you might need to re-index your data to see the change in effect. And that's the bit we want to try and avoid in a way. Because you might have a large index. And what you don't want to be doing is, as you change a synonym, to have to go back every time it's changed and re-index everything. So if you imagine if you have an index of over 500,000 documents, it's going to take a while. So what we want to try to do is avoid that. So, but the first part is we sort of say, right, well, we want to use Node.js to actually use it to build our code. So that kind of sets another context for it, so it knows what language we're using. So it'll switch to use Node.js. And then from that, it knows, well, these are the supported libraries that you can actually currently use to talk to it. So it pulls up the OpenSearch. And then it gives you step-by-step instructions how to install this client. And at this stage, we're still looking at how do we change the configuration with the JSON side of things. So we're looking at how do we set up a project which will talk to the OpenSearch engine and send it the JSON to query it. And again, we're probably going to, that's not, as I said, not necessarily going to work for us. So scroll on down through. So effectively what you're seeing here is, in this bit of code, it's sort of, this is the function, sort of says update synonyms, and it has client indices close, client indices put the settings, and then down here, client indices open. So it closes the index, writes the change, and then opens it back up again. So the interesting part of that is it gives you out the script of how to do and run all of this. So you scroll down past that. Gives you all these are always very apt in fairness, so that you actually always worth reading through to actually see. I've found extremely useful over time. But here's the question: will I need to re-index all the content? And what it comes back with is it sort of says, it doesn't say yes, but it gives you the two options. If you're changing existing documents, you'll need to re-index. But for newer documents, it'll automatically do it. So again, it's not necessarily what we want. So next part of the conversation, one of the bits was, can explain what the open and close do. And that's what I was saying, as part of the functions, when it comes up with something that you don't know, there's a good chance to go learn, sort of go, what are those two parts? What's the effect of them? And from that, back it says, full definitions of what they do. So when you close an index, it becomes temporarily inaccessible for read-or-write operations. So very much, obviously, definitely something we don't want to be doing as part of, if you're running a service that's dependent on search, that it suddenly stops everything, makes the change, index stuff, and then wait a bit for it to come back up. So, and this then obviously runs through the open part as well. So basically makes the previous close index accessible again and applies it. So effectively closing just pauses it, and we run stuff against it, and then we open it back up again. So as you can sort of see, though, these type of things, it's a series of questions and sort of part of the conversations that you have, and it's sort of, you're trying to teasing out the information that you want to get out in the end. So it's not like a sort of a one prompt that you'll get the actual answer for. Some of the stages, though, you can actually go back to the end of it and actually say, what would have been a much better question to ask you in the first place to get to this stage, so you can actually bypass them. Another good way of learning how to prompt better. So in this scenario, we're going to suggest to it a way of sort of saying, instead of adding the synonyms to the index, could we write some code which would analyze the phrase the user sends and sees if there's any synonyms in a matching file and include that in the query. So it's kind of giving it, we know how it does this, but we want to go down that particular path. So it comes back and actually goes, absolutely. You can pre-process the user's search query and use like a query time expansion. And by doing this, you can dynamically modify the user's query. So in that scenario, then by doing that, means we're not going to have to re-index it because it's just going to build at that query time. So, and as part of that, it gives you a basic outline of how you might, the different parts that are involved in it. One is like maintaining a dictionary of your synonyms, which is the part that will get updated by the users as they add new synonyms to be queried. And then pre-process the search query. So basically run it against that, see what the synonyms are, adapt it, and then expand your query and run it against OpenSearch. And it starts off then with the sort of scroll up a bit more, sort of a basic implementation. So you have our synonym map, and we can sort of see cell phone, and the synonyms for that are mobile and smartphone. And then the other one is laptop and notebook. So it's come up with those synonyms and add them to the file. So what we'll do is, we notice down here at the bottom, it sort of adds an OR to the actual symbols. So, but how we're actually going to run it doesn't require an OR. So we've actually wrapped that elsewhere. So we're just sort of saying we're going to tell it to ignore that and basically just use a space instead. So, but it comes back to warn you of you know, if it, because it still assumes it's doing it the other way, and say by taking out the OR, it's going to make sure everything has to be there. But in fairness, I haven't actually told it the way I'm going to query it, so it's assuming the original part that it's used. Now, in fairness, I don't update it, but it infers from the next few queries, and it gives me a full list of the why I shouldn't do it. However, at the end, it tells me if I want to do that, then I just need to update that line of code there to remove it. So the next part is to sort of say, I have a particular set way that I want to actually do those strings. So I'm saying this is, however, I know we started like that, but I want you to start with having an array of strings. So I'm going to give you an array of strings, which is how we've already stored it. And I want you to use that as the starting structure. Picks that up and said, okay, if they're stored in this way, where each string contains a word and a synonym separated by a space, you can modify the code in this particular way. So again, they give sort of the two bits of code together separately. So it's the initial part, which is the top of the file, and then the actual, the other main part of the file. So, which is useful. However, I'm going to be very lazy and just tell it, you know, instead I prefer if you sort of gave it to me all at once. So I said, can you show me all the code as one block? So just means it'll instead sort of pop it up for us, and we can copy it. So what we're going to do is just copy the code. Here's a simple project I created earlier. It was one that we're using the other side, but it's simply just going to be one file for storing this code that we're writing, and then there's a second, there's a package that sets up any libraries that will be used, but in our case, it was just setting up a test file as well that we're going to use after that. So if we paste in our code, save it, and run it. So what we'll see is we started with the cell phone deals. And what it's done is it's expanded that to include the mobile, smartphone, and deals on top of that. So it's added in the additional synonyms for us. What we thought we'd do here then is then say, right, well, let's update it so it can handle acronyms or just expanded synonyms in multiple lines. So in this case, where we see AWS, we would be able to search for AWS and Amazon Web Services. So it sort of says, adding that, multi-word synonyms, you need a slightly more sophisticated approach. And it gives us an updated version of that. And it also includes what we've added in. So again, we can copy that and just we'll paste it and save it. And what we'll have a look at is this is our query, AWS Cloud Solutions. And when we run it, we get Amazon AWS Web Services Cloud Solutions. So, which again works as we wanted it to work, but we're going to want to push one step further again. So there's another sort of iteration. So in this case, we sort of said, if we did a test and we put in the opposite way around, so where we'd expect Amazon Web Services to also include the AWS, which is the acronym part, it actually comes back, it hadn't done that. So if we put in that test, it would come out with Amazon Web Services Cloud Solutions. So exactly how it was. So it's we're effectively only doing it sort of unidirectional. So it's actually picked up and he goes, you're right, unidirectional code, meaning it maps from the key term. But we wanted to actually work in a bi-directional way. So in one way and then back the other way as well. So we should get it. As part of that then, it now gives us its updated version of the code. So where we see we have Amazon Web Services Cloud Solutions, and we'd expect to get that plus the AWS back. You can see that's what I was saying earlier. You can't always trust that it knows exactly what it's doing or it's interpreting it exactly right. So the best way to do this is actually sort of take it and pass it back. So sort of feeding it back in to sort of say, kind of worked, but this bit's broken. So with the above change, I get this. So it comes back and apologizes and realizes that it's iterating over the terms incorrectly. So and what it says, we need to refactor the way they're handling the synonyms to avoid it. So again, it gives you the revised code with the changes that it's made. And what we'll do is we'll test that one more time. Yeah, and now we get the correct answer. That's great. Sort of feedback that say you're going, great, that works. So can you help me to build out a test file? And in this part, what we want to be able to do is actually not only build the code, but build the tests as well. To get, sort of say, by testing the function thoroughly. In this case, another way of actually questioning would be to make sure you execute all paths within the code. So actually then go back and update the data. What it suggests is that I told it what I wanted to use, using Mocha and Chai. So it uses that. So Mocha and Chai are two node libraries that we use for testing. So it knows about them, it knows how to use them, and it starts off by telling you what you need to install as part of your project. And it creates the code for the test. What we'll do is we'll copy that and we'll actually put it in. What we'll do is we'll run the tests. And we see we've got 4 errors. So as part of that, again, this is sort of, as I said, reading the fine print. At the bottom of the code, it says to make sure to add your exports for the other file. We copy that and add it back in, and we try it again. So this time round, it's executed, should expand single word queries, should expand multi-word queries, and we have 1 error. Should map terms bidirectionally, which is obviously one of the things we wanted to make sure that it worked for, and it's failing. So here it sort of says, right, assertion is expected set mobile smartphone to be an array, but obviously it's not an array. What we do is, again, we just feed that back in. And this is a way of actually also explain what we did. So explained, I renamed your file from one to the other. So this is what we're using. And when I run it, I'm now getting this error. So then it picks it back up. It sort of says, right, well, it's meant to be an array. What it actually does is it just updates that particular function. And I think we're nearly there, but one last part. It's sort of picked up the fact that we've now, it's not, our test isn't working. We've cell phone and smartphone. So effectively, at this stage, we kind of look at that and you go, we know those 2 answers are right. but still coming up with the error. So it's obviously, it has misinterpreted well, I suppose what data it originally passed it. So again, we passed the data back in, and it sort of says it looks like it's failing because the mobile term only maps back to cell phone, not both cell phone and smartphone. So it indicates a flaw in how the map was constructed, but it then has a look back and it goes, upon rereading the code, it seems correct. The logic takes the term and maps it. So it's actually going, no, I'm actually correct. So I pointed out to it, looking at the cinema map, there's 2 entries for cell phone. So it comes back, yes, it's an issue relating to that. So it gives us an update for that particular setting up the top here. And now if everything is passing. So it's just those sort of steps. So the final bit is, I suppose we've gotten to write some code. We've got it to write the tests. I suppose the final bit, which is the last bit we want to sort of look at, it's like, oh, great, that worked. Can you create me a README? So effectively at this stage, then it generates instructions that you'd include along with the file to sort of say what its features are, how to set it up, and its usage, and how you might include it. Now, obviously, you sort of see due to, there's a bit of a bug they have in there, because obviously within the code, they have open and closer files for the wrapping the actual code part, the markdown, but unfortunately everything else is also embedded with it, so it actually ends up writing it there. But as part of that, you can you generate it so it can be copied? And I say, sir, yeah, here you go, here's the unrendered markup. But again, unfortunately, it gets it mostly right, but still the last few bits. So that's, I suppose, kind of a longish walkthrough of a conversation with ChatGPT, but it just shows you how you can get it to do stuff, how you want to work with it, but also how you got to be careful of what it actually generates for you. You'd assume reading it that you'd sort of go, God, that's absolutely right, and then you go, oh no, it's wrong, and it goes, oh yeah, no, I was wrong, and it has no problems admitting it's wrong when it's wrong. So yeah,
brilliant.
So that was it. So.
That's very good. Anyone got any questions for Jonnie? Anyone?
Yeah.
John? Yeah?
At the very beginning, you said acting as an open search expert.
Yes.
What's the difference between saying acting as an open search expert and saying something like, within open search, explain this?
Yeah.
If you tell it to act as something, does it behave differently to it?
Yeah, I suppose you're setting the context for it. You're setting the context to say, right, you are an open search expert. And then you ask it the next bit of the question. So it's that next part on. Otherwise, you're assuming that it's going to infer which of the bit is the most important to you. So you're kind of sort of upfront setting, I'm interested in somebody answering this question as that particular expert. And sometimes if I find it's useful, you can sort of do it with acting as both a Node.js and an Amazon expert. So they actually sort of put the two hats on, and then it's sort of, and then ask it again the sort of start of the questions.
Are the answers different? Or
Yeah, absolutely. I mean, that was the reason the answers are actually different. Even if you ask the same questions on a set, you'll get different code. Which was, because it was interesting because I was trying to work it out because we were set bugs, and then I ran through it the second time and there was no bugs. So I was like, okay, so and I hadn't really changed because I had copied and pasted the same answers. That's also another interesting one. It was so that was the reason I think had I done it live, could have gone terribly wrong. it would have gone terribly wrong. So it's, yeah, so it was.
Charles?
Do you ever sort of take the output of one and stick it through another?
Yes. Yeah, absolutely. And it was actually ended up doing that for. It was actually generating images. So it was sort of being able to generate images for the Bing. What's the name of the Bing one?
The Copilot?
No, the Bing image generation.
Oh, the Bing image generation.
Yes, DALL-E. Yes, yeah. And I tried it and put in through ChatGPT to generate and then pasted it into that. But no, definitely it is one that you can compare how one would answer it versus another, or given that I have this, is this correct? So you can actually get them to cross reference.
Yeah.
So, yeah.
I've tried that. It's quite interesting.
Oh, it's really interesting.
Yes.
Yeah.
No, he's wrong.
Yeah.
Any other questions? Do you want to say anything at all about Bedrock, or you want to save that for a rainy day?
I think we save that for rainy days.
Okay.
it's,
Yeah. Cool. So yeah, anyone know what a Bedrock is? There's somebody in the audience who might know. But yeah, Bedrock was announced at the last AWS summit, wasn't it?
Yeah. And it's
sort of
it's private beta at the moment.
Yeah.
But it's Amazon are going to be providing some LLMs that they have themselves, but then also provide hosting for other data models. So I think Hugging Face is one of the places where they have a lot of sort of open-tuned models that you can leverage and use. And I suppose from that scenario of where that's then useful is that you can take in trained models and direct it at your information where it's not being fed back out, but it's isolated. So you're actually having a model that you can use against it, which then opens up an awful lot of other interesting
Absolutely.
parts.
As you say, watch the space.
Yes,
Right.
definitely.
Very, very good. Great. Thank you very much, Jonnie.
Cool.
Yeah, it was very good. Yeah, thank you.
Cheers.